Hi guys, hope you are doing well guys. Look, today I'm going to teach you how to fill the electron in the orbital by using above. Above principle is not the name of the scientist, it's just a principle. I'm going to start atomic structure, and atomic structure, you know, that is the biggest topic, and in that topic we have so many subtopics like structure of the orbit, like velocity of the electron, radius of the electron. So many topics are there. How the electron move around the nucleus. I will teach all those subtopics later on. But before that, I think first I should explain how to fill the orbital with the electron by using this principle. That's the above principle. So I'm giving you a brief description of the structure of an atom. Look at that. This is nucleus. We know that nucleus has proton plus neutron. We are not going to discuss about the proton and neutron, and we are not going to discuss today about the nucleus. So nucleus, around the nucleus we have so many circular paths which we call them as orbits. These are orbits, energy level. So these are the orbits. Where the electrons are present. These are the orbits or shells or energy level. You can call them as orbits, energy levels, or shells. Okay, because the energy of the each orbit is fixed or quantized. I will tell you how to work out the energy of the each orbit later on. But today's topic is that how to write the electronic configuration of any element present in the periodic table. Now see that each orbit has many subshells. So in the orbit, we number and name the orbit. We number the orbit as like n is equal to 1. The first one is n equals to 1, n equal to 2, n equals to 3, n equals to 4. So the first one is close to the nucleus, or K, L, M, N. We name like K, L, M, N, or n equals to 1, first energy level, second energy level, third energy level, fourth energy level. When you go away from the nucleus, the energy of the orbit decreases, and the energy of the orbit increases. The first orbit has minimum energy or less energy, and the maximum energy of the electron in the orbit equals to 0 when it is going to infinity. So the energy is negative and is going to be positive. Okay, so the first shell, this is the first shell, or we name them as shells. We name them as SPDF. There's a meaning like sharp, profound, diffuse, like that. So each shell we named as SPDF. Each shell has subshell. So each shell has subshell, guys. Subshell, which is also named as S subshell. Then the P subshell. Then the D subshell. Then the F subshell. So each shell has subshells. I want to rub this, and I want to give you an example. How can we understand the structure of the atom by resembling it's like a big building? Assume that The atom is like a big building. Let's see. And definitely you will enjoy this explanation, guys. And you, after my lesson, you can write the electronic configuration of any element in the periodic table. Look at that one. So I told you F buff is the principle. It's not the name of the person. It's just a principle. Look at that. So this is like a big building or apartment, tallest building of the apartment. It has levels: level 1, level 2, level 3, level 4, like this. Level 5, L1, L2, L3, L4, L5. In the same way, this is the nucleus, and nucleus has proton and electron, and around the nucleus we have circular path. What we call them? We call them as orbit. So these are the orbits. So orbits resemble as like the floor or the levels. Floors, these are the floors. Level 1, level 2 are the floor. Each building has many floors. Some building has more than 10 floors. So this is the nucleus, and these are the orbits. Orbits, or for the sake of understanding, you can assume that these are the levels. Okay. In each level, we have some flats, or we call them as suites. Suite 1, suite 2, suite 3, flats, which is nothing but subshell. So I told you, suppose this is my S shell, that's the P shell, this is D, and this is F. So each shell has subshell. S has S subshell, S shell has S subshell. What does it mean? So each shell has some space inside that, like each level has, each floor or level has flats or flat or suite. In the same way, each shell has subshell. P has P subshell, P shell has P subshell, P subshell. D has D subshell, D shell has D subshell. Subshell means like in the shell we have one more space, small space, which we call as subshell. Now, F shell has F subshell. Okay, that's clear, yeah? So each floor, which is nothing but like SPDF shells, so that's S, that's P, that's D, that's F. Okay, each floor has flats or suites. In the same way, each shell has subshells. P subshell has P shell has P subshell, S shell has S subshell. It's like a small space inside the main energy level. That's my main energy level. This is the sub energy level. Okay, now when you zoom in, sorry, when you zoom in, each subshell is anything further present. Yes, when you zoom in each subshell, we have orbitals, guys. So each subshell has orbitals. Like when you zoom in each flat, I want to zoom in the flat. Each flat has rooms. Definitely, a flat without room or suites without rooms is not possible. So rooms just resembles like orbitals. So orbitals are nothing but, okay, I will write what is meant by the term orbitals. Orbital. Orbital is different from orbit. Orbit, why we call them as orbit? Because the electrons are rotating around the nucleus in a fixed circular path. That's why we call them as orbits. Now, orbitals, each subshell has orbital. S subshell has S orbital. So they have orbitals. What is meant by the term orbital? It is a space or it is a region. It is a space or region where probability of electrons are there, or where electrons are there, where electrons are present, where electrons are present. It's a region or it's a space where there is a probability of electron. What does it mean? Where electrons are present. It's just a 3D. Actually, some teachers they said that space, electrons and the orbitals are the same thing. The region where the electrons are present, we call them as orbitals. So it's a space. So it's a space or the region. There's not a fixed shape for the orbital because they are moving in 3 dimension. We are drawing their shapes. Okay, so each shell has subshell. Like floor is nothing but like shells, like level 1, level 2, level 3, level 4, level 5. Okay, each shell has subshell. So each floor has flats. So each shell has subshell. When you zoom in the subshell, we can find orbitals. So flats has rooms. Now inside the rooms, who are present? Inside the rooms, people are present. The peoples are nothing but the electron. Same way, so in each orbital, electrons are present. How many electrons are present in each one orbital or 2 orbital, we will see. And how can we fill the orbitals with the energy level? Okay, can I rub the board? S shell has S subshell, which has 1 S orbital. You can assume that level 1, which is S shell, it has 1 subshell, so it has 1 flat, and that flat has how many room? Just 1 room. S shell has S subshell, which has 1 S orbital. Shape of the S orbital. Shape of S orbital. Spherical. There's a difference between the spherical and circular. The spherical is a 3D and circular is 2D. So shape is spherical. It's like a football, and all these electrons are concentrating. Okay. One more scientist, he gave a principle called Hund's rule of maximum multiplicity, or we call it as Hund's rule. So according to that one, we can have only 2 electrons in each orbital. We can't put more than 2 electrons in one orbital. Okay. He said that you can't put too many electrons in one orbital. So assume that each room we can have a 1 person or a 2 person maximum. So the space of each room is max 2, minimum 1. In the same way, the space of each orbital It's for 1 electron or 2 electron. It can accommodate 1 electron or max 2 electron. Okay. Now, how many electron we can fill in s orbital? Only 2. Only 2. Number of electron in s orbital. Number of electrons in s orbital is equal to 2. Minimum 1, max 2. Now, come to the p shell. Suppose this is my p shell. P shell. Okay. Second level. Now, p shell has p subshell. P shell has p subshell. P shell has p subshell. And p subshell has, look at that. P shell has, P shell has, the P shell has, P shell has p subshell, which has 3 orbital, which has 3 orbital. And we can name, how we can name them as, we can name them as px, py, pz. Why? They are on the x-axis. They coordinate on the x-axis, y-axis, and z-axis. They are called, or they are named as, they are named as px, py, and pz. Now, this is my x-axis, x coordinate. Okay, like this is my x coordinate. That's the x coordinate. This is the y coordinate. This is the y-axis, and the z-axis perpendicular. All they have 90-degree bond angle, and that's the z-axis. This is the z1. I can use a different board marker, different color board marker, and that's my z1. This is the z1. All are perpendicular. So look at that. This is the x-axis. So we have the p orbital on the x-axis. What is the shape? The shape of the p orbital. Shape of the p orbital. Shape of p orbital is like elongated S or dumbbell shape. So this dumbbell on x-axis, that's on the y-axis, and one is on the z-axis. So px, px, py, pz. How many orbitals? 3 orbitals. We can also represent orbitals like boxes. 1, 2, 3. Px, py, pz. And according to the Hund's rule, we can have 1 electron minimum in each orbital or maximum 2. So we can fill 1, 1, 1, then the pairing start. First, we have to fill the orbital with 1 electron, all the orbitals with 1 electron. Then after that, you can start pairing. You can start pairing like this. Okay. Now, so P shell, like my second floor, which has S shell, and the P shell, which has two flats. Okay, S flat or S suite and a P suite or P flat. It has only 1 orbital, and we can fill maximum number of electron as 2, and it has 3 rooms. It has only 1 room, and it has 3 rooms. Look at that. And each room, some persons are present, parents are there. 1 room for the parents, 1 room for 2 sons, 1 room for 2 daughters, like that. Okay, now next, D shell. Look at the D shell. D shell has D subshell and it has 5 orbitals. 5 orbitals. D shell has D subshell, D shell. So it has S, it has P, it has D. D shell has D subshell, which has 5 orbitals. They are named as, they are named as, they are named as DXY, DYZ, DZX, dx square y square. It's not minus sign. It's not minus sign. The last one, dz square. 5 orbital. So D has 5 orbital. It has 1 room. It has 3 rooms, and that D flat or D suite has 5 room. 1, 2, 3, 4, and 5 room. Okay, look at that. What's the shape? You can ask this question. So what's the shape? Yes, shape of D orbitals is like a 4 lobes, like two elongated like 8, elongated 8, and one more 8 like this. So it has 4 lobes like this. The shape of the D orbital is double dumbbell. P is just dumbbell, it's double dumbbell. Double dumbbell. These three, the lobes are in between the axes like this. And these two, that one is on the axis. And the DZ is slightly, look at the DZ, how the DZ look. D actually it should be dx and dx square dz square. So x orbital become is like a circular, is like a plate like stuff, and we have only z orbitals. So it's like this one, and that's the circular one. When you compress this elongated 8, it become like a circle. It become like a circular stuff. So you just compress that one. So for d z square, we do not have 4 lobes. We have only 2 lobes. That's the shape of d orbitals, and how many electrons we can fill in each orbital. 2. The number of electrons in each orbital is minimum 1 and a maximum 2. So how many? D has 5. D has 5 orbitals. Look at that one. D has 5 orbitals. D has 5 orbitals. 1, a 2, a 3, 1, 2, 3, 4, a 5. So we can fill 1 electron, then 1 more electron, 1 more, 1 more, 1 more. Then the pairing start. Hund's rule said that we can have only 2 in each orbital, minimum 1 and a maximum 2. So S suite has only 1 room. Small flat, it has only 1 room. P flat or P suite has 3 room, 3 bedroom flat, and this is 5 bedroom flat. In each bedroom we can accommodate minimum 1% and a maximum 2% in the same way. Did you get this? Okay. Try to understand the concept, guys. Once you learn the concept, it is easy to answer all the questions based on that. I want to stop my topic here, and in my next video I want to teach the shape of F orbital, and how can we fill the orbital with electron by following F-buff principle. I hope you enjoy my today's lesson. Please keep on watching my all videos. If you have any question, please write it down in the comment box and send to me. I will definitely answer your question. Thank you so much.